Example 1, 4 liters of an ideal gas. So again, I see the words ideal gas, I know it's this kind of problem. Immediately, once I see that, I'm going to put P1 equals V1 equals T1 equals P2 equals V2 equals T2 equals. So as soon as I see ideal gas, I'm immediately looking for this information. And what I want to get is all the initial stuff. I want to make sure all the stuff related to each other goes together. So 4 liters, that's volume, of an ideal gas at a temperature of 800 kelvins at a pressure of 100 newtons per square meter. I do expect proper units to be used in this, so make sure that we're paying attention to that. I'm writing my units down. Whatever units are on the left are going to be the same on the right. And one requirement that I don't think I mentioned, initial temperature, final temperature in degrees Kelvin. Does everybody know what Kelvin is?
Yeah.
Okay. So negative 278 degrees Celsius is absolute zero. Or is it 298?
That was 273.
270. Let's go 273.
Yeah.
Negative 273 degrees Celsius is absolute zero. That's the lowest temperature possible. I don't know how they determine that, but that's what they say. I'm going to believe them. I'm not a chemist, I'm not a physicist or anything, but I've heard that negative 273 degrees Celsius is the coldest it can be ever, anywhere. If you add 273 degrees to that, you get 0 degrees Kelvin. All Kelvin is 273 degrees more than Celsius. It starts at absolute zero and then it goes to the same level as Celsius. So 2 degrees Celsius is 275 degrees Kelvin, 0 degrees Celsius, 273 Kelvin. So it's just a simple addition subtraction thing. I want to go from Celsius to Kelvin, I add 273, Kelvin to Celsius, I subtract 273. And later on when we revisit these problems, they're going to throw in degrees Celsius instead of degrees Kelvin. You'll have to do some conversions because this requires kelvins to be used. So, but for now it's going to be kelvins, so don't worry about that. Yeah. All right. But again, whatever the units are here, newtons per meter squared, liters, Kelvin. The units are going to be exactly the same. So make sure you're establishing units when you do this. Okay, the volume were increased to 10 liters. Okay, now be careful with this. They do it just very few times, but they do it sometimes. If it says the volume were increased to 10 liters, that means the new volume is 10 liters, right?
Yeah.
If it said it was increased by 10 liters, 4 plus 10 will make 14 liters. So just be watchful for that. If they change up the wording a little bit there, that's a place where people have messed up.
Increased by 6.
Again, is it going to happen anytime soon? Probably not, but it's going to happen at some point because I remember it happening at least once or twice and people getting wrong answers because of it. So just be cautious how they're increasing or decreasing. The temperature reduced to 600 kelvins. So again, reduced to, not reduced by. So they're just giving us the new temperature. What would the pressure be? That's what we don't know. So we're looking for that. And again, I get all that information. I get 5 numbers. I've got a 6 variable formula. P1 V1 over T1 equals P2 V2 over T2. Just to get me some room here. Alright, so if I substitute all my numbers in that I know, P1 100, V1 4 over T1 800 equals P2 we don't know, V2 is 10, and T2 is 600. You create this proportion, it's a basic proportion. Keep in mind proportions can be reduced horizontally, vertically. You don't have to do this. Calculators calculate things. So if I did 10 times 800 times P2 and 100 times 4 times 600, that's fine. I like to reduce, so I'm going to do that. Goes into that 8 times. That goes into that 2 times. That goes into that 61. That looks pretty good. All right. So if I cross multiply now, I end up with P2 times 1 times 2 is equal to 1 times 60. So we end up with the final pressure is going to be 30. And again, that's newtons per meter squared. Reducing horizontally is allowed also, but just to keep it simple, that's a fraction reduce, that's a fraction reduce. And cross multiply to reduce the fraction. It's usually easy enough at that point. If you can't reduce a whole bunch, then again use a calculator. this times this times this on one side, this times this times this on the other side, then divide.